Okay, let's say you're looking for, you have a truss, like this. And they give you A, B, C, D, E. And they give you a load, let's say, a load P, right? And they tell you, look for the force in this one, in the BC component. So what do? First, you need to know that these pins have force in the y direction and another one in the x direction. Force EX, force EY, and the same thing for the A components. So what you do? Okay, to solve this problem, you're going to have to use a method of cross sections. But in order to get a method of cross section, you first are going to have these forces. So the first thing you do, you solve for these forces around one of these points. How do you do that? If you take some of the force in the y direction, you will get two unknowns, and you won't be able to know it. So you take a sum of moments at E or an A. In this case, because we're looking for this component, we're going to take a summation of moments at E. So we make summation of moments at E is equal to 0. Okay, so you have this yes, summation of moments at 0. You have this force and you have this P. So your summation of moments is going to be equal to, no, sorry, I got it wrong. You're going to make summation of moments at point A. Because you're going to use the method of cross section, so you want this load to be able to solve for this part, not this one. Okay, so you got your moment around point A. Let's say this distance is x, and this distance is x again, to make it symmetrical. So summation of moments is going to be minus p times x, p times x, plus this force Ey times 2x's. And 1x, 2x. This one doesn't have a component because it goes through the A point. So now in order to get the Ey, you just solve for the force Ey. The force Ey is going to be equal to p times x over 2x, and this is going to be your force Ey. Now, to get the force in BC, you use the method of cross sections. So you cut the pin, and then you get these loads. You put all of them in tension. You got a force BD, your force BC. This is the one you're looking for, and your force AC, I think. Yeah. And then you have these loads P and force in the y direction that we already know what is it. And you also have your force in the x direction, but you really don't need that. So we have this force in the y direction. So what will we do? If we make a summation of moments in the x direction, we're going to have a summation of forces in the x direction. We will have this one and this one. We won't be able to solve for this one. We cannot make summation of moments because the same thing will happen. We'll have too many unknowns. So what we do is we make a summation of forces in the y direction, because we have this force that we know it, and this force that we know it, and we have this force that is the one we're looking for. We just have to get the component force in the y direction. So what do? We make summation of forces in the y direction is equal to 0. Then you go force in the Ey minus P plus force PC, that is the thing we're looking for, times opposite over hypotenuse, so this is a sine. We know this angle, it's 45 degrees, I guess. But yeah, we can get that angle easily, so I won't do that. Times the sine of the angle. And then you just solve for CB, or this equal to 0, in order to get the solution for this problem. So your force in BC is going to be equal to this is AY is equal to PX over 2X. So we're going to do that. PX over 2X plus P minus P extended. And then we have the sign, so that will be a negative sign. So then it's going to be, the answer is going to be sine to the minus 1, or negative sign of the Px 2x plus P. And this is going to be your solution for the force in CBC. Force in BC.